Hello everyone. Today we are going to start the complex number. But before we go to the complex number, let us have some information about the real number, right? Real number can be represented on the number line and it can be classified as a rational and irrational number. Real number can be classified as a rational number and irrational number. The rational numbers can be represented as the fractional number. Rational number is actually the fractional number with no common factor. That means the fraction number in the reduced form is called as rational number. And when this rational number is converted into decimal form, it gives you either terminating decimal or non-terminating but repeating decimal. This is the definition. This is how we describe the rational number. And then we have irrational number. This irrational number cannot be expressed as the fraction number, right? And when it is converted into decimal, it is neither terminating nor repeating decimal, right? So this is called as real number. Real number means it is a set of the rational and irrational number. Okay, but in mathematics later on in the 16th century, it was found that just having the information about the rational number and irrational number is not enough, right? Because there are some situations where we get some number which is beyond this rational number and irrational number. So we will discuss now on those numbers. In quadratic equation, we see the situation somehow like this. Sometime we get it as x square minus 9 is equal to 0, right? If we get this situation, then we can find out the solution by writing x square is equal to 9, and then a square, when it goes to the other side, we say x is equal to plus minus root over 9, which is equal to plus minus 3. So here we get the solution for x and we say that the solution exists. But there are situations like where you get x square plus 1 is equal to 0. Now this also could be a situation in the quadratic equation, right? Where when you calculate the value of x, what do you get is x square is equal to minus 1, and then when you shift this power sign to that side, then it becomes x is equal to plus minus root over minus 1. Now this situation is very peculiar because we don't have any solution for this. We cannot define that what could be the value of x, right? Because when the radicand is negative, then we are not in a position to define this. Is it okay? So for such a situation in the 16th century, there was one mathematician called as Euler, right? Euler. We call it as Euler, right? He introduced our number, right? In the 16th century, there was a mathematician called Euler, right? We write this as Euler, but then its pronunciation is Euler. Euler was a mathematician who introduced the notation for such kind of number, right? He said that we require something beyond than the rational or irrational number. We need something beyond rational number and irrational number, and he named it as imaginary number, and he said that the value of this root minus 1 will be equal to I. He introduced this numerical value, and this value is read as imaginary number. I stands for imaginary number. Clear? Now from here he calculated the result, and then he said when we square on both the side, then we get the value of I square as equal to minus 1, because you know, like when you square it, the radical sign and then square and square root will cancel each other, and therefore the value of I square is equal to minus 1. So the first value of I is root over minus 1. Another value of I square, on squaring it, we get this as I square is equal to minus 1. From here we can also have, again if you square it, then it becomes I square and then square it. The value of the power of I will become equal to 4, and then when you square on the right hand side, this will turn into 4. So from here we can draw a conclusion that if the power of I is in the multiple of 4, then the value of this imaginary part will be always equal to 1, right? So keeping this three information in mind, we will start some of the questions based on imaginary number. So today we are going to have with imaginary number. With this, we are going to start some few questions of exercise 21A. This is about imaginary number, right? The question that we have, very simple question, very basic question, is first of all 3i times 2, right? This is very simple. You just multiply the real number by real number. So this is 6i as the answer, right? Another question we can say is number 2 is I times minus I, right? So when we multiply imaginary part by imaginary number, this plus minus will remain as minus, and then this I into I will become I square. We know the value of I square. This is minus 1 as it is, and we know the value of I square as minus 1. So when we multiply, the answer comes as equal to plus 1, right? Similarly, we have another question as negative I multiplied by negative I, right? Now, negative will become positive, and then I into I will become I square, and the value of I square is again minus 1, so plus minus will become as minus 1. Clear? One question we will take is number 6. The question is root over negative 25. Root over negative 25. So here what we can do is we can separate the sign from the number. This will be equal to root of 25 times root of minus sign, minus 1, right? Now this minus, this root of 25, the square root of this 25 will be 5. So this will be out of the radical sign. And this root of minus 1, its value is equal to I. So therefore the answer is 5I. This I to the power 13, we can break down this power as I 12 plus 1, right? And then we can use the reverse of the product law, where we can write this as I 12 times I to the power 1, right? Now, this I to the power 12, this is the fourth multiple of 4. That means the value of this we can write as I to the power 4 times 3 and then into I, right? So, when you have the power of I in multiple of 4, then the value of this part will become equal to 1. And this is into I. This is equal to finally I. Therefore, this is the answer. Now, we are taking question number 15, where I to the power is, the question is I to the power 18, right? This is very simple. Once again, we can break this as for 16 plus 2, right? 18 we can write as 16 plus 2. We can use the reverse of the product law. Then it will become I to the power 16 times I to the power 2, right? Now this is the power, this power 16 is the multiple of 4. That means the value of this I to the power 16 will turn into 1. And then I square is equal to minus 1. Therefore, 1 into minus 1, the answer will be negative 1. Is it very clear? Next we will take is question number 17. This question is root over negative 4 plus root over negative 16 and then is minus root over negative 25. Now we can see here all the radicands are negative, right? So what we can do is the number we can separate from the sign. As a result, this negative 4 we can write as 4 times root over negative 1. Similarly, root of negative 16 we can write as root over 16 times root over negative 1. And then minus sign, and then we can do the same thing with negative 25. Negative 25 can be written as root of 25 times root of minus 1. Right? Now, as a result, this will turn into 2 and this will turn into I. This is plus 4 and this will be again I. Minus sign, this will be 5 and then this will be I. Right? Now, out of these three quantity, 2 of them are positive. So, we will first of all add these two. This is 6I and then this is 5I. We can simplify. Finally, the answer is 1I, that is equal to I. Is it okay? These are all very simple basic questions. Now we'll take question number 19. Question number 19 is negative root over negative 7 over 4 minus root over negative 1 over 7. Is it okay? Now, this question, what we can do is, once again, we will separate this minus sign from the number. This is minus, and then we can write this as root over 7 over 4, and then root of minus 1 minus root of 1 over 7 times root of minus 1. Hope this is clear. Now, after this, what we can do is here this part will be written as I. The value of this will be also I. Now in the first radical part, minus sign, the denominator of this first radical number is a square number, so this will come out of the root sign, so it will become root over 7 over 2, and then this is I minus, now in the numerator here it is just 1, numerator is just 1, so 1 is everything, we can use it as perfect square, so the square root of 1 is 1 only, therefore numerator will become as a whole number and the denominator will be as root of 7, and this is I. Is it okay? Now we need to simplify these two. We need to simplify. Now for simplifying this one, before that we need to take care of this part, right? This is to be rationalized. We will first rationalize and then we can simplify this two. The first fraction number will remain as it is only, root of 7 over 2 I minus. Now we are rationalizing this part. So when we are rationalizing, we will multiply, this is root over 7. We can multiply and then divide by the same number, root over 7 I. This will become then minus 7, root over 7 over 2 I, and then minus 1 into root 7 is root 7, and the denominator will become root 7 into root 7 is simply 7 I. Right? After this, now we are going to simplify. When we simplify, we will make this 2 into 1. LCM of this both will be simply 14. Cross multiply, minus 7 root 7 I, and then this way we can cross multiply. This is minus 2 root of 7 I. Now both are negative, so the answer of this part will be negative 9, because the coefficient of this root is 7 and this is 2, both will be added. This is 9 root of 7 over 14 I. This is your answer. Now क्या बेटा,
अभी अब स्टार्ट किए हैं,
हाँ
मुझे वहाँ तक में चले जाते इसलिए मैं फटाक से
ठीक है
कंटिन्यू कीजिए.
ठीक बेटा. Now we are taking question number 20. This question is again very simple question. As you can see on the board. To simplify this, we can start like this: 1 over I as it is. First of all, we will simplify the power. 1 over I plus 1 over I square, right? This is as it is only, and then here you can write this as this we can factorize, right? We can write this as I to the power 2 plus 1, right? And this last power we will keep as it is only, because we know the value of I to the power 4, no? So we will keep as it is only. Just one we have simplified. Now after this we will start writing the value. 1 over I we will keep it as it is only for the time being. This I square will become minus 1, right? 1 over minus 1. 1 over minus 1, right? And then this power 1 over, we can write this I square plus 1 as, we can write as I square times I, and then this will simply become 1. I to the power 4 value is equal to 1. Now this is 1 over I. Now this 1 over minus 1, we can write this as simply minus 1. And then here this I square will again turn into minus 1. So this will give us minus 1 over I. And then last one is 1 over 1 means simply 1, right? Now you can see here this and this is cancelled. This is cancelled. The answer of this question we got it as equal to 0. Is it okay? Now let us take one more question. That is question number 23. This question is I plus 2I square plus 3I cube plus I to the power 4. I to the power 4. Right? This is our question. So now we are going to start simplifying this. First we will keep this I as it is only. Then this I square value is equal to minus 1. Therefore this will be 2 times minus 1. This is 3I. This 3, and then I we can write as I square times plus 1, right? And this I to the power 4 we will keep it as it is only, because the value of this part is equal to 1. So this is 1. Now is equal to, this is I, then 2 into minus 1 is equal to minus 2, then this 3I to the power 2 plus 1, this 3 is 3, and I to the power, this we can write as I to the power 2 times I to the power 1 plus 1. Now next step, I is as it is, minus 2 is as it is, then this I square will turn into minus 1. So minus 1 into this whole thing, it will be equal to then minus 3I, and then finally this is 1, right? Now this 1 and this minus 2 we can simplify. This 1 and this minus 2 we can simplify. This will come as equal to minus 1, and this minus I and this minus 3I will be equal to this, sorry, this is plus I and this is minus 3I. This will be equal to minus 2I, and therefore this is your answer.